we have developed a relationship between object position and image position for refraction at curved surfaces, which is in this form: mu upon v minus 1 upon u mu minus 1 divided by r. This is air, this is glass. We can also generalize this thing. If you say this medium is mu1, this medium is mu2, then mu is basically refractive index of medium 2 with respect to 1. Light rays are coming from medium 1 and they are entering into medium 2. This is nothing but mu2 divided by mu1. And therefore, we can rearrange this format like this. This mu is mu2 divided by mu1 whole divided by v minus 1 upon u. This mu2 divided by mu1 minus 1 whole divided by r. Now if you multiply mu1 on both sides, mu1 left side as well as on the right side, then this equation becomes mu2 upon v minus mu1 upon u mu2 minus mu1 divided by r. This is the generalized form for refraction at curved surfaces. It's very easy to remember this. First you will have V, U, R. With V means what? Medium of, V means image, and therefore you will have medium of image, which is mu2. U means object, and therefore you will have the medium of object, which is mu1. You know that object is in air and image is in what? Glass. Object is in mu1, image is in mu2. With V, that is the image position, you will get the medium of image. U, which is the object position, you will get the medium of object. And on this side, simply mu2 minus mu1 divided by r. This is something which we have already done. Now, let's also find image magnification with the help of refraction at curved surfaces. Note down this much and then look at this part. Suppose we have an object and we are interested in finding its image. So what do? You take one ray like this. This ray is coming from air and is entering into glass. Optical axis, it behaves as what? Normal at this point, and therefore if you say this is the normal, then this light ray will bend towards the normal like this. This is your incident ray, this is the refracted ray. Let's say this object is represented by AB. Top is A, bottom is what? B. Now, what normally people commit a kind of mistake. This is the refracted ray, and then they go for this refracted ray. They will take a ray coming from B as it is moving along the normal. It will move like this, and then they say that we have got two refracted rays and we need to find the intersection point. Well, if you look at the intersection point of these two refracted rays, it takes place at this position, which is the optical center. But this argument is not correct. Why it's not correct? This is the incident ray which is coming from B. This is the refracted ray for object B. Whereas this is the refracted ray which is coming from the object A. And therefore you cannot intersect these two refracted rays which are coming from different points. When we say that intersection of two refracted rays that gives you image, they both should start from the same point. That means you will have to take a second ray from A. You will need to find its refraction, and then once you get the refracted ray, you will find the position of image of A. Now, suppose you take a refracted ray like this, which is coming from A. If this is the ray which is coming from A, then this refracted ray, let's produce it backwards like this. This refracted ray, you will draw a normal at this point. That's the normal. Once you say that light rays are moving from a rarer medium into a denser medium, they will deflect towards the normal. And therefore, you can say that the refracted ray from this point will move like this. Now, if this is the refracted ray, then intersection of this with this, it takes place somewhere here. This is the point where image of A forms. If this is the point where image of A forms, then what we do, we create an image like this, and then we say that the topmost point, its topmost point is A dash for the image of A, and this bottom represents B dash. So this is the object and that's your image. This image A dash B dash, we need to find magnification formula for object and image. Now, in this ray diagram, if I do not take my refracted ray like this, instead somewhat like this, a little less deflection, then intersection will take place somewhere here. A little less deflection, that means intersection will take place somewhere here. Thoda sa और कम, then intersection will take place somewhere here. But the thing is that every time this ray intersects with this ray, that intersection will definitely take place somewhere on this line. This is what is the important thing. What is the important thing? Look here again. We have the curved surface. This is the optical axis. That's the object. This point is A, the topmost point. From A, we have this ray which meets at the optical axis, and then it goes like this one. If you produce it, then it looks like this. Now what? Every time this second ray, it meets with this first refracted ray, it will either take place at this position or at this position or at this position, but that intersection will always take place somewhere on this line. That means we can say that our image formation, let's say, take place somewhere here. If this is the image formation, this bottom is B dash, this is B, and the top part is A dash. Now what is the advantage of this? You don't have to draw the second ray. That part is clear from this. Now with the help of this part, you can see some easy things. This optical axis behaves as what? Normal, and therefore this angle is angle of incidence, which is I. This is the refracted ray, optical axis is the normal, and therefore this angle is what? R. That means we have the information of sine I upon sine R. What is the information of sine I upon sine R? Sine I upon sine R is refractive index of medium 2 with respect to 1. Now, for small angles, this sine I upon sine R can be approximated with I and R for small angles. And then again, for small angles, this I and R, it can be approximated with tan I and tan R. So your sin I upon sin R ultimately becomes what? Tan I upon tan R for small angles, which is refractive index of 2 with respect to 1, and you write it like mu2 divided by mu1. And the moment you arrive at 10 is what? Perpendicular upon base. Look at this point. If I take optical center as P, then what is tan I? This angle is I. What is tan I? AB upon BP. So this tan I becomes AB perpendicular upon base. Base is BP divided by tan of R. If this angle is R and you are producing this refracted ray backwards like this, that means this angle is also what? R. If this is R, then what is tan R? Look at this perpendicular, A dash B dash divided by the base, which is B dash P. So this becomes A dash B dash divided by B dash P. And this is mu2 divided by mu1. Mu2 divided by mu1. Now, when we write AB, A dash B dash, BP, B dash P, you know that all these things are what? Distances, and they are always positive. If somebody says AB, A dash, B dash, B, P or B dash P, then these are distances, and therefore they are positive. But if I ask you what is U, then U is taken with proper sign. object is on the left side of the origin, this optical center is considered what? Origin, and therefore BP, which is on the left side, as our distance is positive, but U is minus of BP. Similarly, V becomes minus of B dash P. B dash P, if it is 8 centimeters, then if I ask you what is V, you will say minus of 8. If BP is 10 centimeter, and then I ask you what is U, you will say minus of 10. Similarly, AB and A dash B dash, they are what? Distances. But if I ask you HO, which is the height of object. Now remember, this time height of object is taken perpendicular to the optical axis. In refraction at plane surfaces, when you took HI and HO, they were along the length of the optical axis. But in here, HI and HO, they are taken perpendicular to the optical axis. So this AB is positive and so is your HO. HI, HO, U, V, R. All these things should be taken with proper sign. This is origin. Upside is what? Positive. Downside is what? Negative. For us, they both are in the positive direction and therefore HO is AB. Similarly, HI is also what? A dash, B dash. Suppose we got an image which is upside down like this. If image is upside down and let's say its length is 3 centimeter, then you would say A dash, B dash is 3. Still it's 3 because it's what? Distance. But for an upside down image, your HI will be then minus of 3. HI, HO, U, V, R, they are always taken with proper sign when you consider these type of equations. So ultimately, this AB, A dash, B dash, BP, B dash, P, we can now convert all these things with the help of these changes. So let's convert the whole part. This AB is HO. Let's write down HO divided by BP. BP is minus of U. This is minus of U divided by A dash B dash. A dash B dash is HI. Divided by B dash P. B dash P is minus of V. And on the left side you've got mu2 divided by mu1. This becomes, this whole thing you can write in this form: HI upon HO. HI upon HO is what? Mu1 into V divided by mu2 multiplied by U. Negative, negative cancel. Take HI this side, HO this side, mu1 here, V the numerator, and you get this. That's the image magnification, HI upon HO, with the help of refraction at curved surfaces. But instead of remembering this part in this form, look at the trick. HI upon HO is what? This thing, mu1 upon U divided by this part, mu2 upon V. That's how you should remember this thing. V numerator, this multiplied by mu1. This U comes with mu2. So now it's very easy to remember what this format: mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. What is magnification? Hi upon ho. What is that? Second part divided by the first part. You can remember in this form. This is the image magnification. The important चीज थी. You can show this ray diagram, but if you show all these rays, and it becomes complicated and it's not that neat and clean figure. You can show the whole image formation with the help of a ray coming from this side, which is the incident ray, its refraction. Although I have not shown you the second refracted ray, but the point is that second refracted ray, if it meets with the first refracted ray, that intersection will take place somewhere here, 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 or at this place. In any case, this angle is what? R. Whatever happens, this angle is always R. This angle is always I, and therefore sin I upon sin R will be this. So, for image magnification, we can draw this type of figure if we are considering refraction at curved surfaces. Note down everything. Let's see an example on refraction at curved surfaces. Let's take a very basic example. We have a curved surface. Its radius is 20 centimeter. This is air. This is glass. And we have an object of 4 mm height. Its height is 4 millimeters. And this object is placed at a distance of 12 centimeters from the center of the curved surface. The question is, we need to find out everything about the image. Everything about the image means its position, what type of image is it, real or virtual, in which medium it forms, it is upright or inverted. All these things you need to investigate about the image. So write down the question. Find out position and nature of the image formed. Find out position and nature of image formed. Now pause the video, try this thing on your own. If you cannot, then come back and see the solution. Once they give you this much information, first thing is you should write down these values. What is U minus of 12? It's on the left side. What is HO plus 4? This is centimeter. This is millimeter. They will give you as radius as 20 centimeters. But for this surface, you can see that center of curvature lies here. On the right side of optical center, which is considered origin, and therefore R is plus 20 centimeter. These are the things you already know, and you should use them with proper sign like this. Then you will go for the formula which you know. The formula is mu2 divided by V minus mu1 divided by U, mu2 minus mu1 divided by R. That's for the position and all. This side is mu1, this side is mu2. That means mu1 is 1 and mu2 is 3 by 2. Refractive index of glass with respect to air 3 by 2. Refractive index of air with respect to air is 1. Now let's put all these values. Mu2 is 3 by 2 divided by V minus mu1. U is already known, minus of 12. Mu2 minus mu1 divided by R, which is plus of 20. This becomes 3 upon 2V, which is plus, shifted this side, minus 1 upon 12. 3 by 2 minus 1 is 1 by 2, 1 by 40. This is 40 into 12, 12 minus 40. And instead of wasting time in finding LCM, you can simply cross multiply these things. 12 minus 40 upon 40, this is minus of 28 divided by 40 into 12, which is minus 7 divided by 10 into 12, 4, 7, 4, 10. And therefore you get your V as 3 by 2 multiplied by this thing, which is 10 into 12 divided by 7. 2, 3, shift, and you got your V as 3 by 2 into 10 into 12 divided by 7, which is coming to 6, 6, 3, 18, minus of 18, 2, 6, 6, 3, 18 into 10, minus of 180 divided by 7 centimeter. That's the position of image. Now, once you've got the position of image, let's find out height and orientation of the image. For that, you will write HI upon HO, which is second part, mu1 upon U divided by the first part, mu2 divided by V. You do not take the negative sign, just remember the trick. Now, mu1 is 1, U is minus of 12 divided by mu2 is 3 by 2 divided by V, which is coming minus of 180 divided by 7, minus of 180 divided by 7. Now this HI we need, and HO is given as what? 4 mm. Write down 4. Now, at this stage, what people do, they try to convert 4 mm into centimeter. Well, you can do that, but there is no need for this. This 12 is in centimeters, and this 180 upon 7 is also in what? Centimeters. And therefore, centimeter and centimeter, they are getting cancelled. If 4 is in millimeter, then HI will automatically be in millimeter. You don't have to convert this whole part. This gives us your HI as 4. Negative, negative cancel. This is 1 upon 12 and 3 together in the denominator. This 2 is with 180. 2 is with 180. It goes here. 2 into 180 divided by 7. Simple maths. 12 and 3 together. 2 is with 180 by 7. Remember like this. 2. This appears in the numerator. 180 divided by 7. So your HI is 4 multiplied by this whole thing, which is 2, 6, 2, 6, 6, 3, 18, 18, 180, 10. divided by 7. 2, 6, 6, 3, 18, 18, 10. 10 divided by 7, which is coming 40 divided by 7 mm. And the most important thing, it's coming what? Positive. Now once you say positive, we have the orientation of image. Once you say negative, you have the position of the image. This is coming negative, minus. That means this is origin, this side is positive, this side is negative. Image is being formed on the left side. Your HI is coming positive. That means it's an upright image like this. It's not an inverted image. For inverted image, your UI, your HI will be negative, and your image is not getting formed on this side because your V is coming negative. So if you try to locate the position, it will be somewhere this minus 180 upon 7. This minus 180 upon 7 is roughly minus of 7 to 14, 4, 40. 7 5 are around minus of 25 roughly. So minus of 25 means somewhere here. This is the position of image. Now when you say this is the position of image, what is basically this point? This point is the image of B. This point B, which is the base of the object, its image is getting formed. Its image is getting formed at this point. That's your B dash. Once you found that your V is coming approximately minus of 25, that means your position of base of the object that you have obtained. If this is B dash, now object is the final image is either like this or this. Since we know that HI is coming positive, you will say that your image is this. That's your image, and the top is what? A dash. The last thing left. Since this image belongs to mu2, which is glass, but it appears in air, that means this image is a virtual image. It's a virtual image. It is being formed in glass, and therefore you cannot show it like this. You must show it with broken lines like this. So that's your final result. We have found and we have located the image, and we also know its nature. It's a virtual image. It's an upright image being formed in glass. Its position is known, its height is known. Go down everything.